This is the third and final video on the journey to understanding in depth how the fetch the code execute cycle works, which we will look at step by step in the fourth video. Data and signals are transmitted between components across internal connections called buses. Be aware that a bus in computing isn't like a vehicle. It's a set of physical pathways that carry binary signals between components. The computer doesn't put data onto a bus like passengers, but instead sends electrical signals along these connections that are named buses. The data bus transmits data and instructions between the central processing unit, memory, and other components such as input and output devices. It is bidirectional, meaning that data is sent both ways along the bus. The address bus transmits the memory location that the CPU is accessing. It is unidirectional, meaning it is one way, and that's always from the CPU to RAM. The control bus transmits control signals, such as read or write, from the CPU to coordinate other components. It is technically bidirectional, as control signals are sent from the CPU and response signals may be sent back. Now is a good opportunity to look at word size and bus width. Word size is the number of bits the CPU can process in one operation. A larger word size allows the processor to handle bigger numbers, larger memory addresses, and transfer more data per cycle. For example, a CPU with a 64-bit word size can work with words that are 64 bits long. This usually means the registers and memory addresses are 64 bits, and the data bus is often 64 bits wide too, and that is called the bus width. A larger bus width allows more bits of data to be transferred to and from memory in a single cycle, improving overall performance.